Okay, so today we're going to have a look at parametric equations. Now, sometimes it's useful to describe our x's and y's when we're graphing in terms of another parameter, such as t or time. We call these parametric equations. So we've seen this before when we've looked at vectors. So that was when we started at a certain point. You can see here our vector AB, we start at 1, -2, 4, and we move with a velocity vector of 0, -9, and 2. So that describes our time. So we're going to have a look at another few examples of parametric equations. So first, let's have a look at an example. Find the Cartesian equation of the curve which has parametric equations x equals 2t plus 1 and y equals t squared minus t. So Cartesian form is going to be more familiar to us when we have a look at that. So what we want to do first is in Cartesian form, we want to get y in terms of x. All right, at the moment we've got y in terms of t. So we want to turn our x value into terms of t. So at the moment we've got x equals 2t plus 1, but we want to get in terms of t equals. So the first thing I want to do is I want to remove my plus 1 to the other side by subtracting it. So x minus 1 equals 2t. And hence to get t by itself, we divide both sides by 2. So t equals x minus 1 divided by 2. All right. So we can now substitute this into our y. So our y then equals x minus 1 divided by 2 all squared minus x minus 1. So there's a couple of ways to do this. You could expand this out using our FOIL rule, or we could realize that the x minus 1 over 2 is the same, well, pretty much the same in both. And I just noticed that I didn't substitute in over 2 here. So what we see is these two terms, x minus 1 over 2, are the same. And this one here is squared. So we can take a factor of that out the front. So x minus 1 over 2 is the same in both sides. So to get this original equation we had, we need to times the first one because it was squared by the same thing, x minus 1 over 2. And this negative version, we can just write -1. All right. So if we multiply this in here, we would end up with our original function. Okay, so we haven't changed anything. Now, the reason we did this is it's a little bit of a trick. So we get x minus 1 over 2. We can rearrange this second bracket. So if we put, instead of writing 1, we times it by 2 over 2, so we can deal with the fraction. We can change this to, all right, put it over the same fraction. We get x take 1 take 2, so x take 3 all over 2. And we have now simplified that into a Cartesian form. So we got y equals. All right, you could expand this, and what you're going to get is basically y equals x squared, blah, blah, blah. Now, the reason I'm showing you this is because we see that this is going to be a quadratic, and that's what it would look like if we graph this parametric form. So if you did want to graph it without changing it to parametric form, so by the way, we're done with this now, that's finished. But if you wanted to graph this without changing to parametric form, we need to create a table of 3 columns. All right. Now, as our t changes, we can substitute it in for our x. So our x up here. So if we put 0 in, we're going to be left with 2 times 0, 0 plus 1 is 1. And our y is going to be 0 plus 0 is going to be 0. So our first point on our graph would be 1, 0. Second point on our graph, put in 1. We're going to get 2 plus 1. We're going to get 3 for the x. And we're going to get 1, take 1. We're going to get 0 again for the y. We put in 2, we get 4 plus 1, we get 5. On the right hand side, we get 4 take 2, which is 2. All right, and you could just plot these values here as your x and your y. And it's another way instead of moving it to Cartesian form. So we're going to have a go at a couple of these now.